Good morning to all. Today I'm going to discuss about microwave measurements. In previous videos, I uploaded about the general functions of microwave frequency ranges and then elements which present in the microwave system. And next, measurements. So measurements is nothing but in general low frequency circuits, we are going to calculate the current and power relations by using some few parameters like X parameter, Y parameter, and then Z parameters. And but when we comes to the microwave frequency ranges, because it is a very high frequency ranges, so the general frequency of the microwave techniques which covers the frequency range from 300 megahertz to up to 300 gigahertz. So the corresponding wavelength is from 1 meter to 1 millimeter. So these are all the general microwave frequencies. In real-time applications, we are using up to 4 gigahertz based on the requirements and based on the applications. We are using the entire microwave frequency ranges. So according to the frequency ranges, for measuring the power level of the microwave, so here it is very difficult to measure by using the conventional parameters, that is low frequency parameters. So especially for measuring the microwave power levels, we are going to introduce the scattering parameters, that is scattering matrix. So by using the scattering matrix, here we are going to calculate the power level of the microwave measurements. So next, so this is the difference between the low frequency and the high frequency measurements. So in low frequency, that is up to some few 300, below 300 megahertz, we are considering the low frequency ranges, and which we used in the narrow band frequency ranges for general communications. And when coming to the microwave frequency range, the frequency is very high. So at that time, the wavelength is very less. And next one, this is the general waveform of the low frequency and high frequency components. So according to the frequency ranges, the wavelength and time period get varied. And next one, so here in low frequency, the open circuit and short circuit is possible to measure the power levels which present in the low frequency ranges. When it comes to the high frequency, that is microwave frequency, the open circuit and short circuit are very difficult to measure in the high frequency ranges. So this is the main difference in the low frequency and high frequency. And generally, the equipments are equipments are readily available for measuring the low frequency ranges, but in high frequency ranges, it is impossible to equipment is not ready for measuring the general measurements of the power levels. So these are all the main comparisons between the low frequency and high frequency, that is microwave frequency ranges. And next measurements methods. So these are all the some few measurements method in present in the microwave system. So first one power measurements, and next one frequency measurement, third one SWR, that is standing wave ratio measurement, and next one impedance measurement, and S parameter measurement, attenuation measurement, and then noise measurement. So these are all the general microwave measurements method for analyzing the parameters like reflection coefficient and then transmission coefficient. In general, we are using only the S parameter measurements. That is, in S parameter measurement, we are going to calculate only the transmission parameter and the reflection coefficients of the corresponding microwave frequency ranges. And remaining measurements, according to the microwave setup, we can measure the power measurements, frequency, SWR, impedance, and then attenuation, and then noise measurement. Next one, these are all the general parameters we are measuring in the microwave parameters. So first, by using the power measurements, we are going to measure the entire power level of the microwave system. And by using the impedance measurement and then frequency measurement, we are going to calculate the frequency parameter and wavelength of the corresponding measurement, microwave measurement. And next one, reflection coefficient. So the reflection coefficient is calculated by using the S parameter measurement, and similarly in same way by using the S parameter calculation, we are going to calculate the transmission coefficient. So by using the S parameter, we can calculate the both transmission and reflection coefficient according to the frequency ranges. And next parameter is standing wave parameter. Here by using the VSWR meter, we can measure the SWR and as well as the VSWR in the corresponding microwave frequency range. And next impedance and admittance measurements. So by using the impedance measurement method, we can calculate the both the parameters like impedance and as well as admittance. And scattering parameters. So it comes under the reflection and transmission coefficient. And by using the power method, we can calculate the both attenuation and then phase shift of the microwave measurement. And next one, noise. By using the noise measurement, we can calculate the noise figure and as well as the signal to noise ratio, that is SNR. So these are all the parameters we are going to calculate by using the previous methods, that is measurement methods, which I discussed in the previous slide. So these are all the general parameters we are going to calculate by using the measurements methods in the microwave system. This is the microwave bench setup, entire measurement setup. So the same block diagram I discussed in the first video. So here we are using this is the entire microwave setup by using the elements which present in the microwave system. So according to the measurements, the elements get varied. But the klystron power supply and klystron mount with tube and load slaughter line, these are all the general microwave elements. Mostly we are using for all the measurements method. So klystron power supply, mount with tube, and this one isolator. So isolator is a two-port device. So maximum it is used to transmit the power levels in only in one direction. There is no reverse direction. And variable attenuator. So in attenuator, the attenuator main function is it is used to control the entire power level of the microwave system. So it consists of two types of attenuators. One is variable attenuator and then fixed attenuator. So mostly we are using in practical applications, we are using only the variable type of attenuator because we can adjust the power values according to our requirements. So that's why we are using variable attenuator. But in fixed type of attenuator, the level is fixed in the equipment itself. So mostly we are using up to 30 dB we can utilize in the fixed type of attenuator. So if we want to use up to 60 dB, we can approach the variable type of attenuator for the practical applications. And frequency meter. So this is the frequency meter. So according to our frequency ranges, we can adjust the frequency range by using this frequency meter. And this is the variable type of attenuator, isolator, klystron mount with tube. It consists of oscillator. It is mainly for it acts as a generator, and this is the power supply. So according to the frequency ranges, we can adjust the power level in the klystron power supply. And next one, slaughter line section. And in slaughter line section, this is for measuring the input signal and as well as the output signal. We are going to connect the probe which presents in the CRO or either VSWR or meter. We are going to connect the input signal in the slaughter line section. So that's why we are connecting the probe in the slaughter line section. This is the slaughter line equipment. So here we are connecting one by using the dual probe. We are connecting one end in the slaughter line section and another end in either CRO or as well as in the SWR meter, VSWR meter. And next one, load. So it is used to terminate the entire power level of the system. And load depends upon the measurements method. We can use the load and as well as the termination method. And power measurements. So there are the power measurements divided into three levels. First one, low power, medium power, and then high power. For low power, the range is up to 10 milliwatt. And for medium power, the power level is up to 1 watt. And for high power, it is greater than 10 watt. So according to the power levels, we can measure the power measurement methods for the microwave setup. And next one, attenuation method. So for attenuation measurements, here we are going to use, there are two types of attenuation method is there. First one, power ratio method, and next one, RF substitution method. So I already discussed about attenuation. Here we are going to controlling the entire power level of the microwave system. This is the main function of attenuation. So the equation is defined as attenuation in terms of dB, which is equal to 10 log input power by output power. So this is the general formula for calculating the attenuation value for the corresponding methods. So the two important method is one is power ratio method and then RF substitution method. And in next slide, I'm going to discuss about the general block diagram for the both the methods. So this is the power ratio method. So by using two steps, we are going to calculate the power ratio methods. Two steps. So the first one we are connecting general slaughter line section to the output level. And step two, we are going to connect instead of before slaughter line, we are going to connect the attenuation device. So this is the step two process. So in step one, we are going to connect general microstep bench, general microwave bench, which is which consists of all the measurements. So in microwave sources, nothing but here we are using klystron power supply, and then klystron mount with tube is our main source of the microwave system. And next one, attenuator. Attenuator, commonly we are using the variable type of attenuator. And next level, frequency meter. And next one, slaughter line is the main thing which present in the microwave system for taking the input level and output power levels of the entire microwave system. So in slaughter line, we are going to connect the three elements, that is crystal detector elements, components, and then thermistor mount and then power meter. So by using this power meter, we are going to calculate the first level of the power levels which present in the power ratio method. So these are all, this is the general block diagram for measuring the power ratio methods. And next, the second end of the slaughter line, second port is connected to the termination. So the matched termination. So the main function of the matched termination is it is used to observe the entire power level of the microwave system. This is the main function of the termination part. The first port is we are going to connect it in the crystal detector, thermistor mount, and then power meter. And next, when we comes to the steps 2, before slaughter line, here the device whose attenuation is to be measured. So additionally, we are going to connect the device for measuring the power ratio method, which present in step 2. So therefore, the input and output power of the whole microwave bench of the device, which is attenuated, and it is calculated by using the device what we are connecting before the slaughter line section. And remaining elements are same. So additionally, we are adding the attenuation device. This is the main difference between the step 1 and step 2 for the power ratio method calculation. And next one, RF substitution method. So this is our RF substitution method block diagram. So in general, in our laboratory microwave lab site, we are using the entire block diagram for calculating the RF substitution method. So this is the general microwave source and attenuator up to slaughter lines general. And finally, we are by using the VSWR meter, we are going to calculate the power levels which present in the RF substitution method. So this is the difference between the power ratio method and as well as the RF substitution method which present in the microwave system. And first, the same way we are calculating the in previous topic, that is in power ratio method, we are going to connect the power meter, but in RF substitution method we are slightly changing. That is, instead of power meter, here we are connecting the VSWR meter. By using the VSWR meter, we are going to calculate the entire attenuation level which present in the RF substitution method. So in power, that is in power ratio method and as well as the in RF substitution method, we are calculating the entire power level of the entire microwave system by using the two methods. Thank you.